Our first speaker, Marcin Krasnodębski, is a historian of science and technology and an assistant professor at the Institute for the History of Science of the Polish Academy of Sciences. He has worked and published on a wide range of topics, engaging with issues such as the historical analysis of science and environmental policy, transnational knowledge circulation patterns between research institutes, and also green chemistry. So after studying in Warsaw, Maastricht, and Strasbourg, he received his PhD in History of Science and Technology from the University of Bordeaux and held postdoctoral positions at the University of Bordeaux, University of Paris-Saclay, and the French National Research Institute for Environmental and Agricultural Sciences and Technologies. His book, Green Chemistry Avant la Lettre, Pine Institute and Resin Chemistry in Aquitaine, will be published next year in 2024. So Marcin, the floor is yours if you want to present.
Thank you. That's amazing. Thank you for the introduction, and thank you for inviting me to this panel. I will share my screen. Let's see if this works this time. Now, I think that environmental pollution, resource scarcity, energy scarcity, and so on are topics that become more and more fashionable among historians of chemistry. And one of the consequences of this trend is that there is a growing number of absolutely fascinating case studies that teach us that these topics are not new in chemistry by any means. Alongside these case studies, I feel there are also more and more big picture studies on how, for example, environmental pollution was perceived throughout the centuries. But these big picture studies, that is my impression, I may be wrong, correct me if I'm wrong, mostly concern somewhat older periods, the 19th century, the first half of the 20th century. There are fewer big picture analysis of the impact of sustainability on, let's say, the modern history of chemistry. And what I'm doing right now at this very moment in the project I'm leading in Warsaw is to study the way chemists themselves adopted the language of sustainability in an explicit manner over the last 50 years or so. I examine it in the project I'm leading right now, environmental frameworks in chemistry that have been formalized in one way or another. And what do I mean by that? You see, since the 1970s, there has been an abundance, a great number of disciplines, concepts, frameworks, codes of conduct, methodologies, philosophies that aim to integrate environmental considerations into chemistry. And these endeavors sought to explore whether there could be a different type of chemistry, a different kind of chemistry that would preserve our planet's resources, minimize energy consumption, and if possible, actively protect the environment by reducing the amount of waste and the toxicity of final products. What you see here on the slide is a very, very simplified chronology of these many concepts. You can see that environmental chemistry as a separate discipline emerged in the 1970s, followed by soft chemistries in plural, both in France and Germany. These are two different concepts. Then, of course, in the 1990s, there is the famous, the very important discipline of green chemistry that turned into the most successful discipline, environmental discipline within chemistry. Then we have alternative concepts such as sustainable chemistry and more recently one world chemistry, circular chemistry, and many more. Not to forget that aside these concepts, there are also closely related concepts that go beyond chemistry but impact, of course, the practice of chemists. I mean here, most importantly, of course, industrial ecology and life cycle assessment studies, life cycle assessment studies that became a para-discipline on its own recently. Now, all these attempts aimed to infuse environmentalism into chemistry and reconcile the two. And at first glance, it may appear that there is some kind of progress, right? That scientists formulated these ideas, developed them, then proposed new ideas to either replace the old ones or address different aspects of the intricate relationship between chemistry and the environment. However, the reality is far from that straightforward. What we observe here is more of a, it resembles, I would say, sort of a jungle of coexisting and competing frameworks driven by very different philosophies, ideologies, and methodological approaches, each vying for dominance within the minds of scientists interested in chemistry and the environment. And this is, of course, only the tip of the iceberg, because under every single of these terms, under every single of these concepts, there is a huge range of different interpretations. And there are vigorous debates about, for example, how to define greenness in the green chemistry journals, or how to define sustainability in a broader sense. Now, from the point of view of a historian, this is absolutely amazing. This is absolutely fascinating. Let me provide you an example about how these ideas evolved in a kind of unintuitive manner. Let me start by the environmental chemistry from the 1970s. The textbooks from that period present a very broad understanding of what environmental chemistry was supposed to be back then. There were chapters on pollution prevention and abatement. There were chapters on renewable energies, about the challenges of world hunger, or about overpopulation, how chemistry can help in developing new contraceptives, for example. Additionally, many of these early manuals from the 1970s dedicated extensive chapters to the ethics and politics of the environment, often with a very, you can imagine, passionate, militant undertones. However, according to the dominant narrative, at least among the scientists in the 1980s, this narrative may not be true, but this is a different matter, environmental chemistry was very successful in identifying pressing problems, but it did not always offer concrete, solid solutions. Then in 1992, Kenneth Hancock, an influential environmental chemist from the National Science Foundation in the US, initiated a research program on what he called green chemistry. For Hancock, green chemistry represented the next stage in the process of transforming environmental chemistry into an applied science. It aimed to connect chemical synthesis with broader environmental concerns. For him, for Hancock, green chemistry was not a distinct discipline, but rather a sort of way of renewing, of refreshing environmental chemistry that was becoming a major field, a mature field in the 1990s. Now, if you know something about green chemistry today, this statement may be surprising, because today green chemistry and environmental chemistry are seen as very different fields of inquiry. They have diverged over time, so to speak. Today, when we define green chemistry, we say that it primarily focuses on pollution prevention at the level of chemical synthesis, right? On the other hand, environmental chemistry is typically associated with studying the chemical and biochemical phenomena occurring in natural environments. In fact, the Wikipedia article explicitly clarifies that environmental chemistry should not be confused with green chemistry, as they are distinct concepts. This is not at all what Hancock intended when he formulated the definition of green chemistry for the first time. An interesting point, sort of in a parenthesis, if environmental chemistry investigates the natural occurrences, of chemical phenomena and so on, and green chemistry aims to reduce pollution prevention at its source, there is no readily available term, buzzword, or framework to describe specifically human-induced alterations of the environment, or a dedicated discipline focused on pollution abatement strategies. This is like a small parenthesis. This is not super important, but I still find this evolution interesting. The story does not end here, because if you were to consult modern textbooks in something that we call sustainability science and technology, you would find striking resemblances to the environmental chemistry of the 1970s. Some sustainability science textbooks are filled with chapters on chemistry in a very, very broad sense, and how chemistry can solve global challenges. Not only that, due to some concerns, at least expressed among some scientists, that green chemistry is overly narrow, many chemists insist on abandoning the concept of green chemistry in favor of the term sustainable chemistry, which is seen as something broader, but it is not clear whether sustainable chemistry belongs to sustainability science or should be considered a distinct, separate phenomenon, because people working in these two fields, like they are at least institutionally divided between sort of different approaches, different structures within universities. All these terminological complexity poses challenges for scientists who seek to contribute to this ongoing debate. I have been recently studying, this is my article, I've been recently studying supposedly groundbreaking concepts, frameworks, such as one world chemistry and circular chemistry, which were explicitly designed with the intention to replace green chemistry. But when I was exploring their theoretical, like this groundwork led in the foundational articles, I kind of realized that they failed to bring anything new to the table, in a way that scientists coin these new terms for practices that had been very well known elsewhere in other disciplinary communities that developed competing languages, and there are communities that do not talk with each other. And as a consequence, many well-intentioned chemists are simply unaware of the contributions made by their counterparts in other fields, notably in industrial ecology, but not exclusively. I'm telling you all of this to to express this idea that these concepts, these frameworks, they all reflect a deep desire to make things better, to make things more sustainable. However, addressing these challenges, the challenge of sustainability, is not only complex on the technical level, but also on a conceptual level. It is a debate that revolves around about the ideas, about the purpose of chemistry. What is the purpose of chemistry? All these different frameworks developed over the course of years and are rooted in very different, distinct environmental philosophies. To engage in meaningful discussions, we must understand the underlying epistemologies. Oh, my son just came to the room. That was, yeah. What I was trying to say, that the key takeaway from my talk is that you have to go beyond history of science to understand the evolution of these concepts. And in my case, what helped me to kind of position to understand where do these concepts come from, I studied political ecology, and it is within the discipline of political ecology that I found answers on the order of emergence of these different fields of study. So the question of this, the purpose of these seminars is to reflect on the future of history of chemistry, and at least in my case, I found it immensely helpful to precisely go beyond history of science as such, and to reach out to other disciplines, to other sister disciplines, to other connected disciplines, and to avoid being self-referential. I think that history of science sometimes is overly self-referential, and we should reach out. So this is like a short my short take on sustainability and chemistry. Thank you.
Thank you so much for that. I look forward to discussing it further in the general discussion. But before that, let's move on to the next speaker. So Cyrus Mody is a professor in the history of science, technology, and innovation at Maastricht University. As a historian of applied physical sciences in the United States since 1965, he studies the commercialization of academic research, the longue durée of responsible research and innovation, and the technopolitics of scarcity in the long 1970s. He's currently the PI of the project Managing Scarcity and Sustainability, the Oil Industry, Environmentalism, and Alternative Energy in the Age of Scarcity, which explores the long and ambivalent history of oil firms' involvement in alternative energy and global environmental governance. He's also a co-PI in the ERC Synergy grant Nanobubbles. And since receiving his PhD from Cornell in 2004, Cyrus has worked at what is now called the Science History Institute and Rice University. His most recent book is called The Squares, US Physical and Engineering Scientists in the Long 1970s. So this came out in 2022. Cyrus, thank you so much for joining us. And yeah, I really look forward to hear your reflection on this topic.
Okay, great. Yeah, thanks for the invitation. My presentation is going to be a little different, as I interpreted the assignment as a request to meditate on, yeah, more or less what, if anything, makes the history of chemistry distinctive from other fields. So for me, the field has two possibly related features that set it apart. So first, practitioners of chemistry itself and academic historians of chemistry rub shoulders a lot, and indeed are often one and the same people, in a way that I don't think is really the case for history of physics or history of engineering or many other subfields of history of science. So if you just think about some of the individuals listed on the slide that Brigitte showed us, as well as some of the organizations that she mentioned, right? The CHCMS itself, Science History Institute, which of course used to be the Chemical Heritage Foundation, or the International Conference on the History of Chemistry. These are all places where chemists and historians interact often and fruitfully. Maybe that level of exchange was once more common in other fields, for instance, in the history of computing. Maybe you still see it to some extent in the history of medicine, but in general, I'd say that those kinds of exchanges between practitioners and historians have been institutionalized in the history of chemistry in a way that other fields have struggled to manage, which overall I think is really a good thing. And that institutionalization is also a reason why I don't think the history of chemistry is going anywhere anytime soon. I think it's a very much a strong, institutionally rooted and vibrant field of history science. And then the second main feature of history of chemistry, at least from where I sit in that field, is that chemistry itself is almost perfectly balanced between an internalist and an externalist face, and therefore the history of chemistry is always a subfield of the history of science, but it can never be only that, right? So, I mean, if historians of physics always have this possibility to just ask questions like, oh, how was the muon discovered, and not pay that much attention to social context. And historians of engineering really always have to talk about some kind of application, some kind of technology. For historians of chemistry, that middle ground is much blurrier, and they're kind of always in that middle ground. It's always a both and for historians of chemistry, and never an either or. And that means that historians of chemistry are always kind of just at this tipping point where they could write about discoveries and epistemology and ontology and all the topics favored in kind of old school history and philosophy of science programs. And yet historians of chemistry can never entirely forget about applications in industry and social context more generally, and vice versa. Those who write more about the applications, the technology, can never entirely forget that there is this highly technical discipline of chemistry that's attached to those things. And I think that's very much to the credit of historians of chemistry that they really occupy that middle ground. Yet I don't know that they always get that credit. So historians of chemistry in some ways, I would say, got to the contextual turn, the material turn, even the constructivist turn, well before other historians of science. But because historians of chemistry kind of take context and materiality and application for granted, they're just always going to talk about those things. They didn't make a big deal out of what they were doing. And perhaps we could even say other subfields later tried to take credit for what historians of chemistry had been doing all along. So together, those two features of history of chemistry mean that the field can very readily sink roots into other fields like energy history and environmental history, exactly the kinds of things that Marcin has just described, right? Historians of chemistry have the vocabulary and the methods to trace chemistry's ties to all kinds of domains, and they have the institutional backing to bring those topics within the scope of the history of chemistry. So, for instance, but it's a very important instance, I think it's an accident that the Chemical Heritage Foundation is now the Science History Institute, right? Part of the reason for that change was that there isn't, for example, a history section in the Materials Research Society or a Materials Heritage Foundation. So CHF ended up being the home for people who wanted to do history of material science, history of nanotechnology, history of semiconductor physics, history of toxicology, history of biotechnology, all of these fields that aren't as institutionalized as history of chemistry and don't have these ways of kind of branching out that history of chemistry does. And those made history of chemistry's major institution or one of its major institutions capable of becoming an umbrella for much, much more than chemistry. This expansionary character of history of chemistry also, I would say, applies across time and space and social class. So with some fields of history of science, it's quite difficult to imagine that field's topic separated from the jargon and methods and questions of the technical discipline at its heart, right? There's no history of high energy physics without colliders and detectors, no history of electrical engineering without electricity. So it's hard to speak of medieval electrical engineering or history of high energy physics in colonial Peru. But humans have been contending with the chemical and the material world around us forever and everywhere. And so medievalists and early modernists and historians of science in colonial settings have always been, I think, very well represented in the history of chemistry, more so than other subfields of history of science. I think it's fair to say that historians of chemistry have made the global turn somewhat more successfully than some of our peers. It's again, no accident. I think that one of the editors of the Journal of the History of Knowledge is an historian of chemistry, and the other editor is an early modernist who's employed practicing chemists in his group and is very interested in the material and chemical knowledge of early modern artisans. Of course, historians of chemistry shouldn't congratulate themselves too much, particularly the drive toward a more global and democratic perspective is very much a work in progress. But it does seem to me that the field has made an earlier and more sincere start on that project than some adjoining fields. And admittedly, I personally am not such a good example of that, in that my work focuses on quite elite actors, for instance, the Club of Rome. But I hope that my work complements my colleagues in that together we show that chemistry is just everywhere, whether in the most elite settings imaginable or the most ordinary. And indeed, that chemistry is one of the few things that bridges all of those scales and settings and types of actors. Thanks.
Thank you so much. Again, yeah, lots of things to discuss more about. But yeah, before we do that, let's move on to the third and final speaker. Tristan Revells is a historian of modern China, with a focus on industrial history and the history of science and technology, and currently a postdoc at Tsinghua University. He received his PhD from Columbia University, for which he wrote a dissertation on an alternative biofuel program, which emerged in the late 1930s and 1940s. from the research of Chinese and Japanese biochemists and microbiologists. Recently has also worked on a digital humanities project, which uses 3D modeling software to rebuild China's first large-scale ethanol plant from archival blueprints and photographs. Tristan previously also studied at the University of Chicago and National Taiwan University, and he was also a mystery fellow at the Science History Institute, previously Chemical Heritage Foundation. Thank you so much for joining us, Tristan, and yeah, the floor is yours.
Thank you, Sarah, and hopefully everyone can see my slides there.
Yes.
I'll leave them unmaximized just because I'm never very good at navigating when they're fully maximized. So hopefully that's okay with everyone. So I wanted to take a slightly different approach, but hopefully interpreting this assignment in a somewhat interesting way. I wanted to think about the specific research problem as a younger scholar I had in figuring out what the history of chemistry in China actually entailed, because I certainly didn't come from like a history of science background. I was primarily looking at modern China. I was kind of a business and economic historian, and I kind of backed into the history of science by focusing, as Sarah said, on a biofuel program that was started in nationalist China. And sorry, just to provide some periodization there, that's the period roughly between 1911 and 1949. So the fall of the Qing Empire and the beginning of CCP rule, just around 1950. So my particular project is really just examining a government-led biofuel project based on ethanol alcohol that was used to supplement a gasoline shortage in China when the Japanese invaded in 1937. So the long story short is that Japan basically cut off China from the rest of the world. The Burma Road fell, and the only route to supplying China, or free China as it was known then, was over the Himalayan mountains, which was obviously quite a logistical feat. So basically, I became very interested in how the nationalist Chinese government developed this program, and how it kind of ended up really supporting the the nationalist Chinese war effort against Japan. So when I got into the project, I initially started looking for any sort of materials that could kind of help me out on circulation of, ethanol-based knowledge into China in this period, and I kept coming up blank. And so what I really realized is that within my own field, modern Chinese history, we have kind of a very awkward relationship with the history of science. One of the reasons for that is perhaps like the kind of touchstone work is also maybe one of the most problematic. I imagine everyone knows Joseph Needham's Science and Civilization in China, which has it's both a fascinating and very problematic work. It's basically asks, why does China do so well until the 16th century and then fall off a cliff in developing and innovating in scientific ways? And it really intersected with my research in a way that I found very interesting, because Needham's entire work was generated by going over to China during the 1940s and helping research scientists who are holed up in small mountainous enclaves, basically trying to evade bombings. So they take their laboratories and move them underground or into caves and try to continue that work. And Needham was sent over there by the British government to help circulate knowledge between the research centers that were in wartime China, as well as to help preserve any documents when many people thought Chinese would fall to the Japanese. So try to preserve documents that referenced old Chinese scientific techniques or, documented old texts from the 14th, 15th century. So I felt a very personal connection to Needham's work, though the whole time kind of knowing pretty problematic, because I was literally going to some of the same scientific sites that he'd visited when I was looking at my biofuel project. So hopefully what I'm presenting here is like my very short version of a historiography of chemistry in modern China. So obviously, say Needham is sort of the touchstone, in particular volume 5 of this series encompasses 13 books. And I think the last one was written 2007 or 2008, sorry. Really a massively interesting encyclopedia of Chinese scientific techniques spanning from 2 or 3 centuries BC right up until about 1930. The next work is James Reardon's Study of Change. This is like a kind of very classic, modern science type of work of history. Basically, Reardon views the rise of chemical history in China through the lens of the Chinese state. He basically believes there was a pivotal moment between 1911 and 1949 in which China was, if not quite on the level of, say, a Germany or England, approaching the level of Japan in terms of innovation and application of the chemical sciences to its industrial sort of manufacturing. His narrative is that the rise of the CCP in the late 1930s, as well as the Chiang Kai-shek's Nationalist Party's reaction to that rise, which turned the country more militant, basically stymied the growth of chemistry in China and basically led to a lull, or almost like an extinction of innovation. This text was written in 1991, so it's not very long after China emerged from Mao's rule. So it has its own kind of very specific post-Berlin Wall fall kind of flavor on that history. Coming a little closer to the present, I wanted to try to connect some of the Chinese historiography to what I've read from European scholars. So the one I think that will maybe ring a few bells here is Elizabeth Cole's From Cotton Mill to Business Empire. She's a scholar at Harvard, and she focuses on the Dacheng cotton mill in Nantong. Again, this is in the nationalist period of China, so 1910s, 1920s, 1930s. And she basically focuses on the massively successful textile industry that Eastern Seaboard China developed around the Yangtze River in those decades. This is the kind of work that to me really crosses business history, the history of science, and modern Chinese history. And I found like the kind of like crossover to the works on by like Ernst Homburg, the history of Solvay, or those sort of like business chemical histories really have a lot of crossover there. So finally, this is a small plug for a colleague of mine from my PhD program, UNE. She continues the work on the textile industry and the dye industry in China, and has really, I think, asked some very interesting questions about specifically why China became a heavy industrial exporter to the rest of the globe, rather than what it had previously been up to about 1910, 1920, which was the world's largest producer of luxury handicrafts. And her answer kind of goes into obviously politics, but in a more interesting way. I think the way she intersects with the history of science is by looking at the circulation of mechanical knowledge. So basically, UNE analyzes how textile mills and textile machines were imported from Europe and the US, and engineers were brought over to China. However, most of those machines were set up to process much longer stapled cotton or weave threads. And so in the local Chinese context, what she really discovered was that often the machines had to be essentially jury-rigged and re-engineered to be able to process the particularities of the local Chinese textiles and threads that they had to work with. So it's a really interesting combination of looking at kind of like vernacular engineering or tinkering mixed with this kind of like rise of global, circulation of mechanical and engineering knowledge focused around the textile and dye trades. I think I'm running out of time there, so I'll just leave off, Sarah, if that's okay. And we could probably just go to questions. Yeah.
Okay, thank you so much. And thank you again to all three of you for sharing these thoughts. I really like that you each approached it from a different angle, because I think that will actually give us even more to talk about. So we have about, I guess, 19 minutes for discussion. Is there anyone who would like to start us off with a question or remark? I don't see. Oh, yeah, Gary.
Okay, now I can talk. Thank you very much, Tristan, for that talk. In America, there is an institutionalization of the textile industry in North Carolina. It's called the American Association for Textile Chemists and Colorists. And there's a Department of Textile Science at North Carolina State. This is a group that you might want to couple into, because it is a fully international organization. All of the textile manufacturers in the world have a seat at the table at that place. So they might be of some help to you. It's aatcc.org. So that there's and perchance they're interested in history. They hired me to do a lot of history for them. So anyway, and they hired previously, they hired a postdoc to do the history of the AATCC, which helped my work because it started, and all that sort of stuff. So they're historically minded as well as technologically knowledgeable. Thanks.
I'm always happy for a job tip, so thank you.
Thank you. Okay. So yeah, waiting for other people to bring up their questions. I wanted to sort of reflect on some of the themes that I think were in all three of your presentations. And I think one of them, or at least one of the questions that I was thinking about while listening to you was this relationship, which Cyrus also brought up, between chemical practitioners and historians of chemistry, or like historians of science and practitioners of the natural sciences. And I think it really came through in a completely different way in all three of your presentations. So I wanted to ask you about that. Marcin, it seems like you have a really useful history to present to green chemists and environmental chemists, and or something that at least I guess I wrote down what you said. Yeah, that some scientists are unaware of similar contributions in fields outside of their own, and it seems like it would be sort of useful for them to work with you, or at least reflect on that with you. So I was wondering if you get the chance to do that, and how.
You mean going? When I interact with chemists and I discuss?
Yeah, if they, or if if they themselves also see it as being useful.
This is. I mean, it is useful in the sense that you can very, very quickly show to what extent this can be potentially helpful. When I discuss with people that started recently, that got their degrees within the last 10 years, they are often surprised by the fact that there were many topics widely discussed in the 1970s and 1980s, and they are. It is borderline impolite to say what you are doing is not as new as you think it is. It is a bit in this sense. So you could say it is difficult, but I still hope that I can at least direct them towards interesting questions. But the bigger problem is that in my research, I find so many amazing books and publications that were, for example, released only internally. I mentioned in this long list of concepts the German concept of soft chemistry. This is something absolutely amazing. I like, there is a huge literature only in German that you can find in the archives of the German Green Party, because they were affiliated with the Green Party, and it is like a treasure chest you open, and there are insights on both philosophy of environment and the insights on potential applications and so on. So the question is rather how to use these, how to transform these very recent, but still historical documents into something that could be digested and understood by modern chemists, and who should be doing it, and how can I sell these older concepts to the younger generation. So yeah, these are ideas I'm struggling with right now.
Okay, thank you. Yeah, and then Cyrus, so just to keep sort of this thread going, you mentioned this, of course, the historians of chemistry that are often also chemists, and how this is kind of institutionalized even. But you also mentioned the ways in which chemistry or history of chemistry can kind of take roots in different adjacent fields. And do you see like a difference between that contact with the practicing scientist when it does take those route, like when it does expand into different fields, or do you think it's kind of a method that the kind of history of chemistry approach can also sort of spread to other fields? I hope that's clear what I'm saying.
Yeah, clear enough. I think I guess I would say just that the things that historians of chemistry pay attention to that are just kind of always in our toolkit are things that historians in other fields they can be useful to historians in other fields, particularly things like materiality. For historians of chemistry, it's really almost unavoidable, whereas other historians have had to make that turn, and for them it's a real discovery that materials matter.
Yeah. And Tristan, from what you presented, it seems like it's really quite different when it comes to the history of chemistry in China. Do you think that's even like a completely separate subfield, or something that has yet to be sort of really integrated in?
Honestly, and I noticed Victoria is on this call, I think one of the weirdest things for me was discovering how separate the fields are. I really felt like I was putting together a few books, but for instance, in working at the Science History Institute, just going to a few conferences in Europe, the sphere of scholars is very separate. The other point is just that within China or within Taiwan, those scholars are working in a completely separate sort of pool than American scholars who are, intersecting with it. So to me, there's as many as 3 separate fields that are all working almost independently. You can definitely see that change though. Like with, I didn't give the last reference I had, but Eugenia Lean has some work on the intersection of chemical history in China and the international legal system, like specifically in reference to the development of IP and notions of authenticity and how that could be policed across international lines as the 20th century progressed. But yeah, still certainly I think of it almost as its own compartmentalized field that I kind of walk between doors, but don't really feel it's integrated at this point.
Mm-hmm. Yeah, so I guess that would be at least a very good hope to have for the future of the history of chemistry. That kind of like Cyrus also said, it's still a work in progress, right? To take all of this into account. Do you have any questions for each other, or things that you
I have just a quick like a connection about China. I used to work on a huge research center in France, in Bordeaux, which was dealing with pine resin, wood, and chemistry of pine resin and pine wood. And they actually had in the late 1920s quite a few PhDs coming from China to study in Bordeaux these questions. I was kind of surprised when I saw this for the first time. Wow, that's far away to go specifically to the Bordeaux to study these questions. But they were there, and they were not the only people from Asia. There were also Japanese and people from India. So that's just to when you think about the circulation of ideas about exploiting this traditional natural feedstock. This is interesting how far they could reach out already in the 1920s. This is just a quick thought.
I just had one more thought, trying to bring back just that kind of notion of like maybe like the Asia or just Eurasian continent kind of becoming more integrated in this study. One book that popped into my head that I forgot to mention that I think would be, Sarah, as you sort of brought up the topic of like energy resources, going beyond just that sort of like more stratified history of chemical science. I think this is a great book that kind of bridges those divides. It's a little bit of a political history of East Asia. So it has Japan, China in there, but it's really looking at the history of coal and the kind of like development of government strength and state strength through the exploitation of coal throughout East Asia. And so that like intersection of, state power outside of Europe, but, becoming tied into global circulation of coal, energy, energy-based resources is really well represented in that book. So yeah, I think that's one that stands out to me as like a really good, maybe like touch point for where the field could go in the future.
Yeah, thank you for that. Gary?
Following up on what Tristan just said, there are a series of books which have appeared over the last decade that take the global perspective on things like saltpeter, and coal, obviously, one of them. I think that getting a full contextualization will be a big help for the whole field, so that people understand that there's a groundwork, but it gets developed in different ways depending on the society in which it happens. I was also asked to do a lot of historical work for the Cellulose and Renewable Materials Division of the American Chemical Society. And yes, it's the American Chemical Society, but most of the members are not from the United States of America. Most of the members are around the world. And they got a really big kick out of a plenary talk I gave for them on the history of all of this kind of stuff. And immediately people's faces lit up when they realized the grounding of their field in antiquity, in the Middle Ages and in the present. It's not like, high energy physics where you need $1 trillion to get started in the field. So the opportunities to move into areas, both in terms of nations. I'm on the executive board of the history division of the American Chemical Society, and we're forever talking about how are we going to get started in China? Well, that's the answer. There you are. That first you got to be able to read Chinese. That's been a restriction for many people. That's why Needham was able to do it, because he actually could read it. And there were Americans in the early 20th century that could read Chinese and wrote on fireworks. That's was their entree, is that they were, in addition to a professor, they owned a fireworks company in Massachusetts. So the opportunities are huge and the number of people doing it are small. So, we live in an interesting time for the history of science and technology, because there's so much work that can be done and so few people actually doing it. Nobody should be fighting with one another. There's way too much work to do.
I think just to that point, the last thing that came to mind for me was just like, it was very fascinating. I think Marcin brought up the study abroad students, and that point actually in the history of chemical science in China, like in the 1920s, there's just this massive flood of students coming to the US. It was sort of this first, very much paralleled that kind of like 2000 to 2015 moment, when obviously higher education had a big shift of mainland Chinese students studying here. And it was really fascinating to see how many studied with top level not just chemists, but agronomists and sort of agricultural engineers at a lot of the new land grant colleges in the US. They were taking on students from Europe as well as Asia to study, ways to make substitute rubber or to use corn for, whatever synthesized material they wanted to make rayon, these types of things. I think like that's that sort of a flow of students and sort of like minds in the 1900 to 1930 period it seems to me very under-researched, and definitely an area that could be exploited in the future. It's certainly one that I'm interested in.
Yeah, there's someone now at the Science History Institute working on the history. Just your discussion made me think of this, working on the history of rayon and cellulose. So I think you both would be very interested in talking with her. I'll let her know to reach out. Yeah, which is also, I mean, I guess a really great example of, because she works in, so Alice Lovejoy, she works in film and media studies, I guess is the field, but now like doing the history of film, like the actual material of that the film is often it's not really developed on, like cellulose acetate, and that just becomes a really interesting history of taking into account chemistry, wartime developments, all these, just really interesting connections, like even colonialism and things like that. So yeah, I guess another interesting example also of how materials get out all these different things. Okay. Oh, sorry, Tristan, are you saying something? Because I don't. Oh, okay. Sorry, I thought you were
Just talking to myself.
Oh, okay. Sorry. So I guess if no one else has a question or comments. So Brigitte unfortunately had to leave early, but she was able to listen to the presentations and she sent her apologies. Yeah, so I think then maybe we will stop the discussion here, but it was, well, thank you. Yeah, okay, thank you for that, Tristan, sorry. Yeah, so thank you again so much for joining us. Thank you especially to the speakers for these fascinating contributions. And yeah, this is our last meeting for now, but we're trying to make it into a recurring series. So we do hope to see you again in the future. And I know, at least for me, I will definitely continue thinking about it also in the context of the digital festival. I forgot I should have written down the name. I'm sorry. The Division for the History of Science and Technology is going to have a sort of virtual festival on the future of history of science and technology at the end of September, 29th September. So yeah, this type of conversation will definitely also happen there. And in the meantime, yeah, of course, please let's stay in touch and continue talking. So thank you so much for joining us, and hope to see you again soon.
Thank you for organizing, Sarah.
Thank you.
Thank you.